Today we're going to talk about graphing sine and cosine. So first we're going to take a look at y equals the sine of theta. So on our unit circle, we have our degrees, we have radians, and we have our coordinate ordered pairs. So remember that on the unit circle, it was cosine theta, comma, sine theta. So sine, remember, is the y coordinate from the ordered pairs on our unit circle. So we don't always want to graph every single point from our unit circle, so that helps to denote what the key points are for a graph. So let's go ahead and take a look at that first. Before we get there, we want to talk about the period of the graph. So the length of one complete repetition of the cycle is called the period of the graph. This is the horizontal distance before the graph repeats. So one time around our circle we know is in radians 2 pi. If it was in degrees, it'd be 360. So you can graph in degrees or radians, but often we graph using radian measures over degrees because it's more applicable. So when we're sketching the basic graph of sine or cosine by hand, it helps to note the 5 key points in one period. The key points are your maximums, your minimums, and the intercepts of the graph. The intercepts are also where the graph crosses the midline if your graph is moved up or down. So to get the key points, we divide the period into 4 equal parts. So for this parent graph, the period we know is 2 pi because that's one time around our circle. Divide that into 4 equal parts and we get pi over 2, which of course is the same thing as 90 degrees. So up here I have the circle and I've labeled it with 0 degrees, 90, 180, 270, 360. So 90 degrees, remember in radians, would be pi over 2. 180 is pi. This would be 3 pi over 2, and 2 pi would be all the way back around. And then we have the coordinates for each of these points. So remember, since it's a unit circle, this was 1, 0, 0, 1, negative 1, 0, and 0, negative 1. If we're doing the sine values, remember we're using the y value. So 0, 1, 0, negative 1, and all the way around would be back at 0. So notice that happens 5 times. So it starts here 1, 2, 3, 4, 5. So that's why we say there's 5 key points. So when you're graphing these, it's important that you make sure to graph all the key points on your graph, which means you need to label your entire x-axis with the key points. So since our key points go by pi over 2, we're just going to count by pi over 2. So 1 pi over 2. And then the next one would be 2 pi over 2, which we know is pi. Then 3 pi over 2, and then 4 pi over 2 is 2 pi. So notice I just counted by pi over 2. So for my first parent graph, sine wavelength, we know that on our circle, we start at this sine of 0 degrees or 0 radians is 0. Then on our unit circle, the sine of pi over 2 or 90 degrees, we know is 1. Since we're doing radians, I'm going to use radians. The sine of pi is 0. 3 pi over 2, the sine of that is negative 1, and back to 0. So notice there's 1, 2, 3, 4, 5 points, which completes that first wave. So this is our period of our graph, which is one wave or one time around our circle. Notice that the maximum is 1 and the minimum is negative 1. So that means our range is negative 1 to 1. Your domain for these graphs is all real numbers because you can go an infinite many times around your circle. And we also use our minimums and maximums to help us find the midline of our graph. So the midline is the distance between the maximum and the minimum value. So in this case, y would be equal to 1 plus negative 1 divided by 2, which is 0, 2, and 0 in the numerator is okay. So y equals 0 for our midline. I always like to graph that on my graph because I should know that my graph should oscillate back and forth between this midline. If it doesn't look like it's the same distance above and below, then you need to look at your graph. So we can keep going on our graph because remember it keeps repeating. So let's now write another wave. So if I want to write another wave, I'm going to continue my key points by continuing to add pi over 2. So if this is 4 pi over 2, so the next one would be 5 pi over 2. The next one would be 6 pi over 2, which is 3 pi. Then we get 7 pi over 2. And the next one would be 8 pi over 2, which is 4 pi. So we're going to write these values down. So we have 5 pi over 2, 3 pi, 7 pi, over 2, and 4 pi is already there. So at 5 pi over 2, we know the values are just going to repeat. So we're already at 0, so the next one would be at 1, then 0, -1, 0. So notice we're just repeating those values from our circle. We can also do the negative direction, so this would be negative pi over 2, negative pi, negative 3 pi over 2. And if we went the negative direction, so instead of starting at 0 and going this direction, which would be counterclockwise, we're going to go clockwise. So from here, we would go down on our circle, so -1, and then it would go to 0, and then 1, and then back to 0. And that would give us a third wave. So now I see 3 waves on my graph, so 3 times around my circle. So we did a negative direction and we did 2 positive circles. So again, it just repeated those values. So it went from 0, 1, 0, -1, 0 to 1, 0, -1, 0. So you're just going to keep repeating those values over and over. So that's for the parent graph of our sine equation. So let's go ahead and take a look at the amplitude. So we're going to consider the function y equals a sine of x. The distance from the midline to the maximum or minimum is called the amplitude of the graph. So to find the amplitude, you can do the maximum minus minimum divided by 2. And since it's an amplitude, the distance is always positive. So f of x is equal to sine of x is the parent graph for all of the sine functions. So we're going to graph these other 2 functions on the same coordinate plane, identify the max and mins, and fill out this table below. So the first thing I want to do is go ahead and graph my key points from my parent graph. So I'm going to label my x-axis. So 1 pi over 2, then we get 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, 2 pi, 5 pi over 2, that helps you to write them up here and then reduce. 6 pi over 2 would be 3 pi, and 7 pi over 2, and 8 pi over 2 is 4 pi, which is already there. So label each key point, don't skip any, because I am going to be looking for that, because your key points do change when we change the wavelength of our graph, which we'll talk about on a different day. So now I have my key points, and I'm going to graph my parent graph. So remember, we start at, for the parent graph, 0, 1, 0, -1, 0. That's one wave, and I'm going to keep going. 1, 0, -1, 0. That's the second wave, and we'll go the negative direction as well. So that gives me 3 waves. And we just knew that from the last graph. So now let's go ahead and look at g of x equals 4 times the sine of x. So with that 4 in front, that basically means we're multiplying our y values by 4 from our unit circle, right? So before we had 0, 1, 0, -1, 0. So now we're going to be multiplying those by 4. So on our graph, 0 times 4 is 0. 1 times 4 means this is going to go up to 4. 0 times 4 is 0. -1 times 4 would give me -4, and 0. So this would be my new graph, just one wavelength. Notice that for this, we have changed the maximum and minimum. So our maximum now is at 4. The minimum is -4. So that means that our amplitude, remembers the maximum, if we go back up here, the absolute value of the maximum minus minimum divided by 2. So the maximum, which is 4 plus -4, sorry, amplitude, I'm thinking the midline, amplitude is 4 minus -4 divided by 2, which gives me 8 over 2, which is 4. So that number in front, notice is the same as your amplitude. The midline didn't change at all. The midline's the average. So if you take your maximum plus your minimum divided by 2, you get 0. The period's still 2 pi, and the key points are still pi over 2, and the range now is from -4 to 4. So that was the only thing that we changed, was that range value. So now if we look at the next one, we have 1/2 times the sine of x. So if I now take my sine values and times it by half, so 0 times a half is 0. This is a y value of 1, so 1 times a half would give me half, 0, negative 1/2, and 0. So your new wavelength would look like this. So notice your maximum is 1/2, your minimum is negative 1/2. So that means that your amplitude is going to be 1/2, because again, you would take your maximum minus your minimum divided by 2. So this would be 1/2 plus 1/2, which is 1, over 2, which is 1/2. And the midline hasn't changed at all. It's still at 0. Your period 1 wavelength is still 2 pi. We haven't changed that, which we won't be doing till a different section, which means your key points, remember, are the, again, period divided by 4, which is why, again, they're just pi over 2. So negative 1/2 to 1/2 is then the range. Of course, then it says, what is the domain for each graph? Negative infinity to infinity, all real numbers, because we can keep going on and on and on. I just drew 1 wavelength for these. So for my general equation, y equals a times the sine of x, this tells you your amplitude. Which, of course, if you remember from the Ferris wheel, that changes the radius of the circle. So you can count from the midline up, 1, 2, 3, 4, or down 1, 2, 3, 4. So your midline should always be in between those max and mins. And again, if it's not, then you want to check your work. So the general equation that we have is this equation right here. We're going to talk about that in just a little bit. But this a value is your amplitude, and the d value is your midline. So if you look at these equations here, notice there's nothing being added on the outside of our sine, which means the midline is at 0. So let's go ahead and consider the transform function as that is written f of x as a times cosine of x. So first we want to talk about graphing our cosine parent, which we haven't done yet. So if we go ahead and look at a circle. So on our circle, remember the cosine are the y or the x values of the coordinate order pairs. So we're going to start here. So this is 0, 1, 0, 1, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So now on our circle, we're going to be using the x coordinate. So for cosine, it starts at 1. Then it goes to 0, negative 1, 0, 1. So on my graph, the cosine of 0 is not 0, but 1. Pi over 2, which is at 90 degrees, would be 0. Pi is negative 1, 0, 1. So this is the first wavelength of my cosine graph. And if I keep repeating that wavelength, so I'm going to draw another cycle. So if I do another one, it would go to 0, negative 1, 0, 1. So that would be a second wave. And if I wanted to keep going, I could draw a third wave by, again, just repeating those points. So just like the sine graph, we'll notice that this one also has an amplitude for the parent graph of y equals 0. You can see that the graph is oscillating back and forth between this line, and you can count what the amplitude is. So if I go up 1 from the midline or down 1 from the midline, that gives me my amplitude. So this, again, is just y equals 0 is the midline. And we, of course, we know the range is from bracket negative 1 to 1. So if we want to graph these other functions, notice just like our sine graph, what's changing. So the a value in front is changing. This one's 3 and this one's 1/2. So that means that our maximum and minimum, just like our sine graph, are going to change by, instead of 4, now we're using 3. So if I multiply the y values by 3, 1 times 3 is 3. 0 times 3 stays 0. Negative 1 times 3 would be negative 3. 0 and 3. So just like, again, our Ferris wheel, notice that the amplitude became larger, so that means our radius is changing. Instead of using 1, we're using 3. So that would be one wavelength. And of course, you could continue this by graphing another cycle. So if I went to another cycle, it would go back to 0, and then it would be at -3, 0, and 3. So this would be a second wave. And then of course I could draw another continued wave by repeating those points again. So the maximum is at 3, minimum is -3, the amplitude is 3. The midline hasn't changed, neither has the period or the key points, but the range changed from bracket -3 to 3. So for the next one with the 1/2, that means we're going to multiply the y values by a half. So 1 times a half is a half. This stays at 0, -1/2, 0, and 1/2. So this would be y equals 1/2 cosine x, that third equation right here. And of course we have the maximum 1/2, minimum is -1/2, so that changed the range to bracket -1/2 to 1/2. The midline, period, and key points all stay the same. And the domain of the graph is -infinity to infinity, so that hasn't changed as well because we can go an infinite amount of times around our circle. And again, the cosine graph uses the x coordinates on your unit circle. So again, the general equation y equals a times cosine x plus d. We know that a is the amplitude and d is the midline. Kind of like from our Ferris wheel, remember the midline was the center of our wheel, it's the same idea. So our general equation for sine and cosine are as follows. Y equals a sine of x plus d. Notice the d is on the outside of what you're taking the sine of. And a cosine x plus d, same thing. So the absolute value of a is the amplitude, because remember amplitude can't be negative, and this is the formula. Here's the midline formula. Key points are always the period divided by 4. And so remember, we've already talked about vertically stretching, vertically compressing our graphs before. So remember when that value in front with the a value is greater than 1, it's a vertical stretch by a factor of a. If it's in between 0 and 1, it's a vertical compression. And remember, if a is less than 0, it's a reflection across the x-axis. So we're going to go ahead and look at some of these. So let's look at the vertical shift before we do that. So in general, what effect does adding or subtracting a constant d have on the graph of the function? So we know that this is going to move the graph up or down. Which changes the midline. So if we look at these 3 different graphs here, so we have on our graph already the parent graph for the sine of x. We're going to look at the sine of x plus 2 and the sine of x minus 3. So now if this is the sine of x, if we move the midline to plus 2, we know that plus 2 tells us our midline, so that means it's going to be up at 2 instead. Again, I always like to graph the midline on my graph because I know that my graph should be oscillating back and forth between this. If it does not, then I know I did something wrong. So I always like to draw that first. So my midline is at now y equals 2. So I'm just going to take these points and move them up 2. So this goes up 2, up 2, and up 2. So now my new graph first wavelength would be here. And of course, we can keep repeating those values. So the next one would be at 3, 2, 1, 2. So that would be a second wavelength. And of course, that continues on. So now, of course, you can see the maximum is at 3. The minimum is at 1. The amplitude of our graph hasn't changed because that a value in front, which we don't have anything in front, which means it's 1. So for my sine graph, it's 1. So the amplitude is 1. The period hasn't changed. It's still 2 pi, which means the key points are still pi over 2. And the range now is from brackets, our maximum, so minimum's 1 to 3, so 1 to 3. So our minimum to our maximum. If I'm doing my equation with my midline minus 3, that means my graph's going to move down 3. So I'm going to graph my midline at y equals -3. So that means my midline's at -3 now. And I'm going to count down 3 for each of my points. So down 1, 2, 3 from the parent graph. Down 1, 2, 3, down 3. So I'm just always going from the parent graph and then getting my new graph. So that would be the first wave of my new graph. So you can see the maximum's at -2. The minimum is at -4. The amplitude is still 1. 2 pi is the period. Pi over 2 are the key points, because again, remember, it's the period for one wavelength divided by 4. So for all of them, the first wavelength or one wavelength is just 2 pi. And the range would be brackets -4 minimum to maximum. So bracket -4 to -2. So now we've seen what that number on the outside does. So we've seen what the amplitude does. It changes how high or low your max and min goes. And the midline moves your graph up or down, so from y equals 0. All right, so let's go ahead and do multiple transformations. So again, when you are graphing these, make sure you always label your key points on your axes, so x and y. And we're going to graph a minimum of 2 cycles. So these, again, are the general equations that we're using. So A is amplitude. B is going to be changing the frequency of our graph. We're not going to be doing that right now, so don't worry about the B value. So for our purposes, the B value is going to be 1. And D, we know, is going to be the midline. So here, my A value would be here, my B value is here, and my D value is here. So A is 4, my D is -2. B, for right now, we're just going to use 1. We're going to change that later. So that means the period is 2 pi, and remember, the key points are the period divided in 4 equal parts. So for our purposes, for all of these graphs, it'll be pi over 2. Again, we're practicing this because it will be changing in the next section. So you're going to count by 1 pi over 2 on your graph. So 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, then you have 4 pi over 2, which is 2 pi. And if it helps you to write the values up here, you can. 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, 11 pi over 2, and 12 pi over 2, and then reduce them down here. That's fine. Or if you'd rather just do it as you go, that's fine too. So 5 pi over 2 doesn't reduce. 6 pi over 2 is 3 pi. 7 pi over 2 doesn't reduce. 8 pi over 2 is 4 pi. 9 pi over 2, 5 pi, 11 pi over 2, and 6 pi. And then we have -pi over 2 and -pi. And on my y-axis, I have, I'm going to count by 2, so 1, 2, 3, 4, -1, -2, -3, -4. So always make sure you label, because these graphs, when you move them, look so similar. If you don't label them, it's hard to know. So next thing I always like to do is draw my midline. So my midline is at -2. I'm going to draw that in because I know my graph should oscillate back and forth between this. If it doesn't look like that it does, then we need to check our work. So usually if the graph is sine or cosine, I'll draw the parent graph first just to kind of get an idea of how we're moving the graph. So this is a sine graph. So again, if you think about your unit circle, our sine graph starts at 0, 1, 0, -1, 0. So 0, 1, 0, -1, 0. So this is my parent graph. So what are we doing to our parent graph? We're moving it down 2, so down to this midline, and then we're changing the amplitude by 4, so that this first point is going to move down 2 to here. This point moves down 2 to here, but remember, we're changing the amplitude to 4, so if I count from the midline up 1, 2, 3, 4, that gives me my new point. Maybe I should use a different color here. And then here we're going down 2, stays on the midline. This one's 1 below the midline, so this is now going to be 4 below. 1, 2, 3, 4. And then at the midline. So now I can graph my first cycle. And the question asks us to graph 2 cycles, so we're going to go ahead and graph another one. So it says a minimum of 2, so we can graph more than that. So I know my next key point would be here at 2, then back to -2, then at 7 pi over 2 I'm at -6, and then back here. So that would be a second wave. And of course, again, I could keep on going for a third wave to get another one. So we know the domain of this graph is all real numbers. Didn't ask us to write this, but we're going to go ahead. So -infinity to infinity. And the range we can see is from -6 to 2. So in case you do have to write the domain and range, it's good to practice. Looking at the next equation. So for the next one, again, we have our a value, our b, and our d. So remember, it's always the absolute value of a, because amplitude is always a distance, so it has to be positive. So that gives me 2. My d value is 3. My b value is always 1 for these. 2 pi for now for the period, and 2 pi divided by 4 gives me pi over 2 for key points for each of these graphs. So that negative, what does it do to my graph? Remember, that's going to reflect across the x-axis. So on my graph, I'm going to count by my key points. So pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. I'm just using the values from above if it helps you. 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, 5 pi, 11 pi over 2, and 6 pi. And so my midline has now moved to +3. So y equals 3. I'm going to graph my parent graph. So 0, because it's sine, starts at 0, then at pi over 2 goes to 1, 0, -1, 0. So this is my parent graph. So that negative means instead of going up first, if we were reflecting it, that actually means that our graph would go down first this way. So that's how we're going to change it. So I'm going to start on my midline because it's a sine graph on the y-axis. And I know my amplitude is a distance of 2, except for because it's negative, we're going to go down first. So we're going to count from the midline down 2, then back to the midline, then from the midline up 2, and back to the midline. So again, notice that from the midline we went up and down 2, and instead of going up for our sine graph, we went down because of that reflection across the x-axis. So that gives me my first wave. My second wave is just going to keep repeating. So down 2 from the midline, back to the midline, up 2 from the midline, and back to the midline. That would give me my second wave. And again, we just wanted a minimum of 2 cycles, so we can, of course, always graph more. So that would give me 3 cycles, and we could do negative cycle. That would be half of a cycle because there's not enough room to do another one. So that is my graph, and we can see, of course, the domain's all real numbers because our graph continues on forever, and the range now would be bracket 1 to 5. So for the next one, we're going to be looking at cosine. So for this, our a, b, and d stay the same. It's just that we changed the trig function to cosine instead. So a is 4. D is -1. B for all of these is going to be 1. The period's 2 pi for all of these. So 2 pi divided by 4 means our key points go by pi over 2, just like the last graph. So I'm going to go ahead and write this down. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, 11 pi over 2, and 12 pi over 2, which is 6 pi. Notice I always reduce those values. And for cosine, remember if we do our cosine graph, cosine's the x-coordinate, so it starts at 1, 0, -1, 0. So for our parent graph, we have 1, 0, -1, 0, 1. So that would be my parent graph. So our midline is moving to -1. And my graph is moving down 1, but from our amplitude, it's changing to 4. So, and if I move this green point down 1, we'd be right here, but my amplitude is changing to 4, so that means I need to count up 4 for my midline, so that would be 1, 2, 3, 4, so here. This point was on the original midline for the parent graph, so that just moves down 1, stays on the midline. This one was 1 below the midline, so that means from the midline we're going to go down 1, 2, 3, 4, back to the midline, and up 1, 2, 3, 4 from the midline. So our graph moved down 1, and then we changed our amplitude to 4. So you should be able to count up 1, 2, 3, 4, and down 1, 2, 3, 4 from your midline. So that's one cycle. And then if we keep going, we can get a second graph. And if we wanted a third one, we would do the same points repeated. And then of course you could write down what the domain and range is. So the domain's all real numbers. The range would be from bracket -5 to 3 bracket. Let's go ahead and look at this last equation. So for this last equation, again, it's a cosine graph. This is my A, B, and D. So remember, it's the absolute value of A for the amplitudes. The amplitude is 3, but we do have a reflection, so we have to keep that in mind. D is 2. My B value is 1 for all these. Period's 2 pi. So 2 pi divided by 4 means my key points are pi over 2. So I'm going to go ahead and write those down. And if I graph my parent graph for cosine, it starts at 1, 0, -1, 0, 1. Again, if you need to draw the circle, so 1, 0, -1, 0, 1. So then for my new graph, my midline is changing to 2, y equals 2 right here. And for my graph, so we start above the midline usually, but because it's a -3, that means we're going to start 3 below the midline. So down 1, 2, 3, back to the midline, up 3, 1, 2, 3, back to the midline, and down 1, 2, 3. So notice that your cosine graphs always start above or below the midline. If it's a reflection, it starts below. If it's not a reflection, it starts above. And if we keep repeating those values, we would get a second wave. And we repeat it one more time. Oops, forgot the midline point. We would get a third wave. Like I said, notice that cosine always starts above or below the midline. And if we go back here, notice your sine graph always starts on the midline. So I'm going to make a note of that. So your sine graph starts on the y-axis on the midline and goes up or down, and cosine graph starts above or below the midline on the y-axis. So of course, if your A value is positive, we start above. If the A value is negative, it starts below, just like this last graph that we have. And that is it for this lesson.